I am Reggie York. This is a presentation on using a special Excel file when you want to compute the one sample t-test with the set of data that you have. I'm at the University of North Carolina, Wilmington. This presentation is about illustrating how to use a special Excel file that I developed for computing the one sample t-test when you're comparing a set of scores to a single score. One example is you compute the mean pretest score for a group of clients and use this as the single score to which an array of post-test scores are compared. Now, if you have the ability to match each person's pretest score with each person's post-test score, you would be better advised to use the paired t-test. This is where you cannot do that, and therefore you simply compute a mean pretest score, use that one score for comparison to all of the post-test scores in your data. A second example is you have one baseline recording for a single client and you want to compare it to an array of treatment recordings for this one client. What you will need to prepare in order to use this is you'll need the special Excel file designated by me that's available with this particular book. You need to have your own data, which is two different things: a single score that represents the threshold and a set of scores for comparison to the single score. I'm going to use this example for illustration. You have a mean pretest score for depression of 27.6, where higher scores are worse. Higher scores mean more depression, so we want the scores to be better at post-test. Here are the post-test scores for 5 clients. Client 1 had a score of 21, Client 2 a score of 19, Client 3 a score of 29, Client 4 a score of 17, and Client 5 a score of 16. So we're going to put the threshold score into our file, Excel file, and we're going to put each of these 5 treatment scores there. Here is our hypothesis. Post-test scores for clients will be lower than the pre-test mean. What we will get after we enter the data, we'll get a mean post-test score for comparison to the single threshold score to see if it is better. We'll get a value of t, which we can use to figure out what the value of p is. You'll get an effect size representing the number of standard deviations of difference between threshold and treatment scores. You get a chart to see if the p-value, if the t-value you have is significant. Well, I'll show you that in just a moment. Let's look at the present time then at that particular file. Here we go. Here's the threshold score. I entered this 27.6. Then I went over here and I did 21, 19, 29, 17, and 16. I added all those in there. This is your threshold. These are the post-test scores for comparison. What you see you have here, first of all, the mean score for the post-test, 20.4, which is lower than 27.6, which was the threshold score, which represented the pre-test. So our post-test scores were lower as hypothesized. Here is the effect size. If post-test is supposed to be lower than threshold, which is our case, the effect size is 1.55, which means roughly 1.5 standard deviations of improvement here. Now let's look at the value of p to determine statistical significance. We have a little chart here that shows several different values. You can look at a table of t in a book of statistics, probably look it up on the internet very easily to get more data than this. But I've just put here a number of things to give you some general idea. We happen to have an n of 5. We have 5 post-test scores, 5 clients here. So here's the n value. We have 3 different examples of values of n size, sample sizes of 5 with 3 different t values. Our t value was 3.47. See 3.47, 3.47. So we can say that the p-value for our data is right here, 0.01. This indicates statistical significance according to the normal standard in the social sciences. Okay, that's my instruction for doing this. One more thing I want to say, though, if you get a strange little designation in one of the cells of an Excel file that's E-04, E-05, E-06, or whatever, this will be instruction to move the decimal point 4 places, the number of points to the left. In this particular case of 04, for example, if you saw 1.23 E04 in a cell, you would read this as 0.000123 because this means we move the decimal place from right here 4 places, 1, 2, 3, 4. Actually, I'm sorry. This has one too many. It goes from right here 1.23, 1, 2, 3, 4. So it should be 0.00123. That's the way you'd read this particular designation. Okay, I hope that was helpful to you.